Okay, this is going to be part 4 of the series on trigonometric substitution, and we'll do another problem similar to the ones we've done in the first 3. Now, if you haven't done it yet, I would definitely watch the first 3 videos, and they'll show you how we've gotten to this point right here. Now, the first thing, remember, there's a series of steps, and the first step is to recognize what type problem you have. So in this case, we're going to have something squared minus something squared. And I think the first thing we'll do is go ahead and rewrite it like what we've done in the other videos. So I'm going to rewrite this as the integral of, and we'll go over here. So this will be 4, and then here's the x squared. Then I've got the square root of, and then I think I'll put it in this form just like we've done in the other videos. Something squared, so x squared plus, and change that 9 into a 3 squared. So now you've got something squared plus something squared dx. Okay, now again, we'll use the same series of steps that we've used on the previous videos, and what they look like is this. So remember, the very first thing you have to do is to determine which of the 3 forms that you have. Well, let's take a look at those 3 forms and see what they look like. So the idea is if you have the first case, you've got square root of an a squared minus u squared, or it could be the square root of an a squared plus u squared, or it could be the square root of u squared minus a squared. Now in this case, clearly what we've got, if you look at our problem, is something squared plus something squared. So ours is going to be case 2. So what we'll have is case 2. So we'll focus just on a case 2 and forget about the other ones. So the only 2 formulas that you're going to need to solve this will be the square root's equal to a times the secant, and u is equal to a times the tangent. So we just need to remember those 2 rules for this problem. So back to the problem. Okay, now I think we'll go ahead and put those rules up on the corner of the page here. So again, the square root will be a times the secant of theta, and u will be equal to a times the tangent. Now let's go back to the rules and run through the steps here. So the first thing is determine which of the 3 forms we had, and we've done that. Now remember, the next step, you want to change the whole thing from a problem in terms of x into a problem in terms of theta. Well, in this case, let's first of all start with a square root, and we'll take care of the dx and then any remaining x's. So to change the square root in terms of theta, we would have this. Again, we'll just use this little formula up here. So this will be step number 2. So what step 2 says is, and I think I'll do this one in red just to be consistent with what we've done in the other problems. So we've got, in this case, the square root of, now in our problem, we've got x squared plus 9. So we have an x squared plus 9, and we're going to turn that into an a times the secant of theta. Now, just a reminder, we wrote it as x squared plus 3 squared. Now, in this problem, what we've got is u is equal to x, and a is equal to 3. So you'll set it up like that. So when you set this up, a is equal to 3, and you've got the secant of theta, and there is the square root in terms of theta. So now you're ready for the second thing. So what part 2 is, and we'll go ahead and do this one in blue. So in part 2, we're going to change the dx. Now to take care of that, we'll begin with u is equal to the tangent of theta, or a times the tangent of theta. So a times the tangent of theta. Now again, what you know that u is equal to x, a is equal to 3, and you've got the tangent of theta. But again, you don't want x, you want dx, so go ahead and take the derivative of both sides. So the derivative of x with respect to theta would be 3, and the derivative of the tangent is the secant squared. So that gets you to dx would be equal to 3 times the secant squared of theta d theta. So there is dx expressed in terms of theta. So that takes care of step, and actually this would be step 3. Okay, let's take a look at the remaining steps. So we've done step 2, express the square root. Step 3, express dx. Step 4 says express any remaining x's in terms of theta. So let's look back at the problem here. Now in this problem, the only remaining x's is this right here. You've got an x squared. So on step number 4, you've got to express x squared in terms of theta. Now to do that, look at this one right here. X is equal to 3 times the sine of theta. So let's start with that. So if x is equal to 3 times the tangent of theta, tangent of theta. Now you don't need x, you need an x squared. So go ahead and square both sides. And when you do that, you would get x squared is equal to 9 times the tangent squared of theta. So now you know what x squared is. Now those are the 3 pieces you need to change this entire integral into an integral in terms of theta. So let's go ahead and write that down here. And again, we'll look at our steps. So what step 5 says is rewrite the integral, the entire integral now, in terms of theta. So just take each part and change it into what you have. So I've got on step, we'll put step 5 right here. Now you've got the integral, and you've got 4 over, and just use each part. X squared is equal to 9 times the tangent squared. So this would be 9 times the tangent squared theta. Then you've got the square root part. Well, the square root part is equal to 3 times the secant of theta. So that'll be 3 times the secant of theta. And then finally dx, but dx is equal to 3 times the secant squared of theta. And then you've got d theta right here. So that's the way it looked when you first set it up. Now we'll simplify it a little bit if we can. So first of all, you've got the constant 4. You can bring that outside the integral. So we'll make this be 4. Here's the integral. Now, if you can cancel stuff out, go ahead and cancel it out. So in this case, we've got a 3 in the top and a 3 in the bottom. Those will cancel out. You've got 1 secant in the bottom that'll cancel out one of the secants in the top. And the 9 we'll go ahead and bring out in front. So you can't take care of this 9. Here's a constant 9. We'll bring it out in front too, which would give you 4/9. And then the only thing that's left on the inside would be on the top. You've got a secant of theta. Secant of theta. And on the bottom, you've got a tangent squared of theta. So a tangent squared of theta, d theta. Now, this problem is going to require some trig identities. And right up there, there's no integral that will solve either one of these two. But if you use some identities, you can change it into something that you can work with. So let's go ahead and do that. So we'll make this be 4/9 of the integral. And just to remind you on the identities, we'll change it into, think of this as being the secant of theta times 1 over the tangent squared of theta. We'll think of it like that. Now remember, the secant is 1 over the cosine, so we'll change the secant into 1 over the cosine. And 1 over the tangent squared would be the cotangent squared, and the cotangent is the cosine squared over the sine squared. So this is just a couple of trig identities, and the only reason you're doing this is so that you can put it in a form that you can find the antiderivative of. Okay, next thing, you've got 1 cosine in the bottom and 2 in the top. So this one in the bottom will cancel out one of the ones in the top. And then we'll go ahead and rewrite this thing like this. So that's going to be equal to, here's 4/9 of the integral. And then you've got, now what I'm going to do is this, I'm going to take the sine squared in the bottom and move it up to the top and make it be a sine of theta to the -2. Then I've got a cosine theta d theta. Now, the reason you're doing that is here you're going to use use substitution. The derivative of the sine of theta will get rid of the cosine of theta, so we'll do use substitution on this part right here. So you've got to change it into a use substitution problem to solve it. So we're going to try to get rid of that, and we're going to let this part in here be u for the use substitution. So now let's go ahead and run through the use substitution here. If we let u be equal to the sine of theta, then the derivative of that, du d theta, the derivative of the sine is the cosine. Therefore, du would be equal to the cosine of theta, d theta. And again, this part right here matches up with this, and so your substitution is going to be that right there. So this is just a plain old use substitution at this point. So what that's going to do to it, it'll change it into this. This will become, here's 4/9 times the integral of u to the negative 2, and in place of this, just put what it's equal to, du. So it turns, this is just plain old use substitution. Now find the antiderivative of that, which would be 4/9. And then this is going to become u to the negative 1 divided by a negative 1 plus c. Okay, we'll kind of move things around here a little bit and make this be a negative, so a negative 4/9. And then we'll take this u to the negative 1 and move it to the bottom and make it be a u to the positive 1. So this will be u plus c. And then finally, the last thing is to replace u with what it's equal to, and u is equal to the sine. So this will turn into negative 4/9 times 1 over the sine of theta, and then you've got a plus c out here. Now, really, this is the answer to the problem, but it's in terms of theta, so you have one last step to do, and it's just like on those other ones, you've got to change it back in terms of x again. So let's take one last look at our rules. Now, what we've got, we've evaluated the trig integral. Now, remember to change it from a theta problem back into an x problem. The thing we've done on all the problems so far is draw a triangle, label the sides, and from the sides of that triangle, you can turn the trig function back into an x function again. So let's take a look at that. Okay, so let's get back down here, and we'll go ahead and do the part where we draw the triangle. So this will be step 7, and I think I'll put it right here. So what step 7 says, and again, just draw a triangle, a right triangle, and we'll label the sides. So here's theta. Now just this side is going to be the opposite side. This side will be the adjacent side, and this side will be the hypotenuse. So you can always set it up like that. Now, you need to get 2 of these sides from your trig functions earlier, and then the remaining side will always be that square root thing. So to find out the 2 sides we've done, let's go back up to the beginning of the problem. And remember, we started with this right here. X is equal to 3 times the tangent of theta. So let's take that right here, and we'll bring it back down to the bottom and use that to set up the sides of the triangle. So down here, you know that x is equal to 3 times the tangent of theta. We'll divide, and you get x divided by 3 is equal to the tangent of theta. Now remember, on tangent, the tangent is defined to be the opposite over the adjacent. So what that means on this problem is that this is the opposite side, so x goes right here. This is the adjacent side, so 3 goes right here. And the remaining side is just whatever that original square root was in the original problem. So in the original problem, it's the square root of x squared plus 9. So in this problem, this is going to be the square root of x squared plus 9. So go ahead and use your trig relationship to determine all three sides of the triangle. Now, once you've got this, this is what you need to change this problem back into an x problem again. So remember, you need the sine of theta. So what you've got is the sine of theta is, by definition, it's the opposite over the hypotenuse. So in our problem, it would be x, the opposite side is x, and the hypotenuse is the square root of x squared plus 9. So the sine is equal to this. So now you can just put this back up into this thing right here. So take this and bring it back up here and just plug it in right here. So this will be equal to negative 4/9. And then you've got 1 over, and the sine is equal to x over the square root of x squared plus 9. And then close the parentheses and put a plus c. Now really the final step, if you wanted to, you could take, since you've got a fraction in the bottom, turn it upside down. I think we'll go ahead and do that. So that's going to give negative 4/9. And then flip this fraction upside down. You'd have the square root of x squared plus 9 all over x. Put parentheses around that. Then you've got a plus c, and you would be finished. So there's just another example. And you might want to run through it all the way from the beginning and stop the video when you need to. But again, if you just follow, I think we'll move it up here and look at the series of steps again. So you can follow this series of steps. First of all, change the entire problem from an x problem into a problem in terms of theta. Then evaluate the integral in terms of theta. And then finally, draw the triangle and use that to turn the final answer back into x again. So there's another example of use substitution.